Dear students, this is the continuation of the previous video. Okay. Now you will see this example. The sigma 1 is given in cycle form. Sigma 2 is given in cycle form. These two permutations are defined on S5. Okay. Now, what is sigma 1? You write in the permutation form. See, 1, 2, 3, 4, 5. Now here we have 3 cycles, which means here 2 and 3 is not assigned to any element. It assigned itself. So now 2, write 2, 3, write 3. Then you see the cycle. 1 goes to 4, 4 goes to 5, 5 goes to 1, which means 1 goes to 4. So I am writing for 1, 4. I am writing for 4, 5. I am writing for 5, 1. Okay. Similarly, you write sigma 2. Okay. Now, what we are going to check, whether commutative property is true or false for this permutation. Okay. Now you see here, first I am calculating, say compute sigma 2, sigma 1. Okay. Sigma 2, sigma 1 means you first apply sigma 1, then apply sigma 2, you will find the answer sigma 2, sigma 1. Okay. Now you see, first apply sigma 1, which means, see, go here, 1 goes to 4, here 4 goes to 3. So I write here 3. Then 2 goes to 2, 2 goes to 2. Yes. Here 3 goes to 3, 3 goes to 4. So I write. Similarly, you can complete for 4 and 5. Okay. See, sigma 2, sigma 1, I had to calculate. How to calculate? You start from sigma 1. See, start from sigma 1. Then you stop in sigma 2. You write the arrangement here. Okay. That's it. This is the permutation form. How to convert this into the cycle form? You see, here number 2 is not assigned to another element. It assigned to itself. Okay. So now 1 goes to 3, 3 goes to 4, 4 goes to 5, 5 goes to 1, which means 4 cycle. Okay, here as we seen earlier, no need to write here this 2. Okay, because it assigned itself. Okay. Now this has 4 cycle only. Okay. So sigma 2, sigma 1 is this. Similarly, you calculate sigma 1, sigma 2. How to calculate sigma 1, sigma 2? You start from here. Right side. Start from here. Okay. First you do this. Sigma 2, which means now you see, go to sigma 2. 1 goes to 1, here 1 goes to 4. So write 4. See here, 2 goes to 2, here 2 goes to 2. So write here. Okay. See, 3 goes to 4, this 4 here goes to 5. So which means 5. Okay. Similarly, you can complete the remaining. Okay. So sigma 1, sigma 2 is this. Okay. Here also 2 assign itself. So no need to write in the cycle form. But 1 goes to 4, 4 goes to 3, 3 goes to 5, 5 goes to 1. This is 4 cycle. Okay. But you see, this cycle form and this cycle form is not equal, which means sigma 2, sigma 1 is not equal to sigma 1, sigma 2. That's what you are writing. Okay. It's not equal to sigma 2, sigma 1. So commutative property is not true. Okay. On these two permutations. Okay. Now, see, here you will see the definition. The identity permutation is nothing but identity means you see here 1, 2, 3, etc. And again you see in the second also same. Okay. So no change is assigned into the element itself. Okay. So this is identity permutation. Okay. How to write inverse? So the inverse permutation sigma is nothing but sigma inverse is, say, sigma inverse sigma is equal to I. Then we can say that sigma inverse is the inverse of this sigma. Okay. Now we will see through some problems. Okay. Now you see here. Let sigma be the permutation given by sigma is equal to 1, 2, 3, 4, 5. Then this one. This is the permutation. Okay. How to write sigma inverse? Very simple. How to write sigma inverse? Now you see my arrow. Okay. You have to go. You have to start from means bottom to top. Okay, to write the inverse, very simple. Now you see here, this is the permutation, given permutation, sigma. I want to write sigma inverse. How I write sigma inverse? How I write sigma inverse? Now you see, as you know that in the first row, just you write the elements which is in the set. Similarly here also, 1, 2, 3, 4, 5, you write. Okay. Next, what you do to find sigma inverse, I'm telling. See, go from bottom to top. Okay. Now, first you start from the first number, means 1. See here, 1, you see bottom to top, okay, see this direction, okay, see 1 goes to 5, so here 5. Now 2 goes to 1, so write 1. 3 goes to 4, so you write here 4. See here, 4 goes to 3, so write here 3. Now 5 goes to 2, so 2. Okay, how many cycles here? We have 2 cycles. Now you see 1 to 5, 5 to 2, 2 to 1, so 3 cycle. Another one, 2 cycle, 3 to 4, 4 to 3. Okay, so this is the sigma inverse. Okay, this is the way how we write the inverse from the permutation. Okay. Now here we see, suppose cycle form is given, how to find the inverse of the given permutation. Okay, now sigma and tau be 2 permutations in Sn, then sigma tau inverse is equal to tau inverse sigma inverse. This is the property. Okay, now the inverse of any k cycle. See, suppose the permutation is given in the cycle form, then how to find the inverse of the cycle? Just rewrite the elements backwards. See, now you see, right from ak, then ak minus 1. See, right from right to find the inverse of this. Okay, now you will see few questions, a few examples on this. Okay, to compute the inverse, okay, actually sigma is given. What we have to find? We are going to find the inverse. Okay, now sigma we write in cycle form. Actually we can find the inverse directly from this. Okay, but how to use the cycle form to find the inverse? Okay, now see, this is the permutation. I write the cycle form. Okay, from this. Okay, now if I have 2 cycles, see, if I have 2 cycles, this is first cycle, this is second cycle. See, if I have 2 cycles, then how to find the inverse? See, you write the cycle, second cycle inverse, then first cycle inverse. Okay, you see here, sigma is this. I want sigma inverse. Okay, I want sigma inverse. Okay, how to find inverse of this? Which means this cycle inverse. First write, then write the inverse of this cycle. Second. Okay, so 3, 4 inverse. Okay, how to write the inverse of the cycle form? This is given here. You write backwards. Okay, very simple. So 3, 4 inverse is nothing but you write, change the place, 4, 3. 1 to 5 inverse is nothing but 5 to 1. Okay, finish. So now how to combine these 2 cycles to write the permutation form? This we know that 1, 2, 3, 4, 5 you write. Okay, then now 4 goes to 3, 3 goes to 4. So now here 3 goes to 4, 4 goes to 3. 5 to 2, 2 to 1, 1 to 5. So here 5 to 2, then 2 to 1, then 1 to 5. Finish. This is the way how we find the inverse from the cycle form. Okay. Now you see here another example. See here sigma is given. Okay. This is given in cycle form. Permutation, yes, 11. Okay. 11 elements actually in the set. Okay. Now we are going to find inverse. Okay. So how to find inverse? By using the previous property. Now see this. If you put whole inverse, then you write this first inverse, then this element goes to second inverse. Okay, then how to find the cycle inverse, how to write the inverse of the cycle? Very simple, you write backwards. Okay, this 11 first, then 8, then 4, then 3. See here, 8, 7, 4, 2. Write backwards. Okay, finish. After that, actually this is the answer. Actually this is your answer. This is your answer. Okay, but how is possible to write this permutation from these 2 cycles? Okay, I explain in another way. Now you see, from this step to this step you write, then you can write the answer. Okay, now you see here 11, 8, 4, 3, we have 4 cycle. Okay, actually how many elements here? See, 1, 2, 3, 4, 5, 6 till 11. Okay, now here only 4 elements having the cycle. So now I do, see here 11 goes to 8. So 11 goes to 8. 8 goes to 4. See, 8 goes to 4. So 4 goes to 3. So 4 goes to 3. 3 goes to 11. 3 goes to 11. Okay, I write this. Okay, for this cycle, I write one separate permutation form. Then what I do composition, which means I start from here. First you do this, then go here to write the answer. Okay. Now you see here 1 goes to 1, then 1 goes to 1. Okay. So I'm writing this one. Okay. Now you see here 2 goes to 8, 2 goes to 8, then 8 goes to 4. So I write 4. Now 3 goes to 3, here 3 goes to 11. So I write 11. Similarly, you can fill. This is the answer. Okay. So see, this is a cycle form. This is a cycle form. From these two cycle forms, how we write the inverse. See, I am writing to make you understand this cycle into the permutation and this cycle into the permutation. Then I do the composition. Finally, you will get this answer. This is the answer. Okay. Now, that's it. Now, let's say another example. You see, suppose we have n, the positive integer. Then what is Sn comma composite? This is the symmetric group. Okay, n greater than or equal to 3. Okay, what is order of your group G? Which means this is the notation for order of the group G, which means how many elements, means number of elements in G. That is denoted by this two lines inside G, or you can say modulus of G. That is order of a group. Okay. Now, for any positive integer n, the order of the symmetric group, which means suppose I have n is 3. Okay. Then how many elements in Sn? That is n factorial, because for the permutation, we know that we've seen in the first slide 3 factorial. That is n factorial here. So that this is the order of the group, order of the symmetric group. Order of the symmetric group with the n elements is nothing but n factorial. So order of the symmetric group with the 3 elements, that is 3 factorial, that is 6. Suppose we have 4 elements, then 4 factorial, that is 24. Okay. Okay. See in this example, we are going to prove S3 comma composition is a symmetric group. We are going to prove this. Okay. Now, in the given set, we have 3 elements, 1, 2, 3. So that we have 6 permutations. What are the 6 permutations? That is sigma 1. We are giving the name sigma 1, sigma 2, sigma 3, sigma 4, sigma 5, sigma 6. We are writing in cycle form. Okay, this is cycle form. Okay. So now what is S3? S3 is containing all these 6 elements. Okay. So we are going to prove S3 comma composite is a symmetric group. Okay. Now what is sigma 1 is the identity element. That's why I am writing here. You see empty. Means notation is empty. See, sigma 1 is equal to empty. It is not assigned to another element. Means 1 to 1, 2 to 2, 3 to 3. Okay. Now you see here, make you understand I'm writing. I is equal to what? Sigma 1. Sigma 1 is I is identity element. See, 1 to 1, 2 to 2, 3 to 3. This is identity element. Similarly, I can write sigma 2. Actually, this is given here. You see here, sigma 2. Sigma 2 is nothing but 1 comma 2, which means 2 cycle. 1 goes to 2, 2 goes to 1, but in 3, no changes. So that I'm writing here, say sigma 2 is nothing but 1, 2, that is 1 to 2, 2 to 1, 3, no change. What is sigma 3? Sigma 3 is nothing but 1, 3. So 1, 3 means what? 1, 3 means, see, 1 to 3, 3 to 1, but here in 2, no change. Okay. This is the permutation form. This is the cycle form. Okay. So we have 6 elements. Sigma 1, sigma 2, sigma 3, sigma 4, sigma 5, sigma 6. How to fill this table? I explain here. Here, the binary operation is composition. So, for example, I am doing sigma 2, sigma 3. Okay. How to find sigma 2, sigma 3? First, you write sigma 2. See, we know that sigma 2 permutation form, sigma 3 permutation form. Okay. Then, you start from right side. See, 1 to 3, then 3 to 3. So, you write this 3. 2 to 2, here 2 to 1. So, write this. So, 3 to 1. Here 1 to 2. So write this. So now you see here, this is 1 to 3, 3 to 2, 2 to 1. So here 3 cycle we have. That is sigma 6. 3 cycle. What is 1, 3, 2? You go here in the assumption 1, 3, 2. This is called sigma 6. That's why you see here sigma 2, sigma 3. I do 1 for sample. Okay, how to do? I did sigma 2, sigma 3. Answer is 132, that is sigma 6. That's why I'm writing here. Similarly, you do 1 by 1, then fill the table. Inverse. This is the identity element. You see here 132, 1, 2, 3. Inverse of each other.